So I just finished recording the lecture on 14.8 with Lagrange multipliers, and then I was looking at the homework again, and I noticed they have a few that I want to go over. So this is actually the teacher's version. It shows that on average it takes people just a little less than 7 minutes. About 43% get it right on the first try. Of course you have 2 tries, but anyway. So I'm sure they're going to change the numbers here, but you've got an ellipse. That ellipse would look something like this. I don't really need an accurate picture right now. Just the idea. And then a rectangle is inside of it. And then they said parallel to the x-axis and parallel to the y-axis. So that's going to be this lovely little rectangle right here. And this corner point right here would be some point x comma y. So this distance would be x, which means all the way across the top is 2x. This would be y, so all the way down this side would be 2y. So that means that area is going to be 2x times 2y. Now I don't think I have enough space on this paper. Let me change that over. So this is area equals 4xy. So the function that we are supposed to find the maximum of is area equals 4xy. And then the constraint equation would be the ellipse x squared over 9 plus y squared over 16. And then I could subtract 1 from both sides and it's equal to 0. Now take the derivative with respect to x. So that's going to be 4 times y. Over here, take the derivative with respect to x. So that's going to be 2x over 9. And then times lambda. Now take the derivative with respect to y. So that's going to be 4x. And take the derivative with respect to y. So that's going to be 2y over 16. Or in other words, y over 8. And then we need to do algebra. And I actually did this problem before. Before I turned on the camera. And I sort of got bogged down until I thought of this idea. What if you divide these two equations? So just divide them. So on the left side, the 4's will cancel. It'll leave y over x. On this side, the lambdas will cancel, and when you divide by a fraction, you need to invert and multiply. So this will still be on the top, 2x over 9, and then the lambdas have canceled, and invert this and multiply, so 8 over y. Then I can multiply both sides by y, so this side becomes y squared. And that right there is where my brain goes, dang, Greg, that was a good idea. Because now you know what y squared equals, and you'll be able to plug it in over there. I love when that happens. All right, continuing with the algebra, I need to multiply the x over here. So that's going to be what? 2 times 8 is 16, and then there would be x squared, and there would still be over 9. So that's what y squared equals. I can now plug it into that equation. So it's going to say x squared over 9 plus y squared over 16. And y squared is 16/9 x squared. And then I'm just going to move the 1 back to the other side. Okay, so this is basically x squared over 9, and then you could multiply by 1/16, or in other words, divide by 16 on the bottom. You could also divide by 16 on the top, and then cancel, 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 cancel. So what it leaves is x squared over 9 plus another x squared over 9. So I have 2 of them that are x squared over 9 equals 1. And then multiply both sides by 9 and divide both sides by 2. All right, then take the square root. So it's going to be, so usually you have to put plus and minus the square root, but I was talking about this one, which is in the first quadrant. So x is positive and y is positive. So it's going to be the positive square root, and square root of 9 is 3, square root of 2 is just square root of 2. And then it says use radicals as needed, but I have a feeling that they rationalized the denominator, so I'm going to do that. So x is equal to 3 radical 2 over 2. And then substitute that over here to find out what y equals. So y squared equals 16 over 9, and then x needs to be squared. Well, actually I've got x squared right there, so I don't need to plug this in and square it. I know x squared equals 9 halves. So 9 halves. And then these will cancel. And then it leaves 16 divided by 2, so that's 8. And now take the square root, and square root of 8 is 2 radical 2. Now keep in mind that in this picture, this length right here is actually an x plus another x. In other words, it's 2x. So that means that 2x equals 2 times this. And when you multiply this by 2, then it's going to get rid of this 2 in the denominator. So it's going to be 3 radical 2. So it looks like their computer got that one right. And 2y, so that would be this length right here, is equal to this times 2, which is going to be 4 radical 2. And it looks like their computer got that one right. Good job, guys and gals. Everyone's. All right, next up, a word problem. Find the dimensions of a right circular cylinder. So that's like a soda can. And let's say this is the radius and this is the height. The volume, so the formula for volume is you take pi r squared times h. That's volume. And that has to equal 16 pi. All right, that's one equation. In fact, I'm going to divide by pi r squared times h equals 16. That's one equation. Now the next one is the surface area. So for surface area, if you take a rectangular piece of paper, so that's a rectangle, and you make it round like this, then that's like a soda can. And going around the top of the soda can, that's going to be the circumference. The formula for circumference is 2 pi times the radius. So if you then cut this can right down here, and then you open it up, it's actually a rectangle. And on the top would be the circumference, and the height would be h. So surface area is going to be 2 pi r times h. Now before I go on, I need to reread the question, and oops, it's closed. So that means that it has a top and it has a bottom. So I need to add to that. Area of the top would be pi r squared, and then the bottom is the same, so there's going to be 2 of those. All right, so there are the 2 equations. Let me switch over. So I've got r squared h equals 16, and I've got the surface area is 2 pi r h plus 2 pi r squared. Okay, now take the derivative with respect to r. So you got 2 variables, r and h, so take the derivative with respect to r. So I could move the 16 over, and then it would be a negative 16, and the derivative of negative 16 is 0. Or I could leave the 16 right there, and the derivative of 16 is 0. So no matter what, the 16 is going away. So take the derivative with respect to r. This would be 2r times h. Now over here, take the derivative with respect to r. So this would turn into a 1, so there would be 2 pi h. And over here, you bring the 2 in front, and it's going to give you 4 pi r. And then all of that is times a lambda. Now take the derivative with respect to h. So over here, that's just going to be a 1 times r squared. Take the derivative with respect to h. So this is going to be a 1 times 2 pi r. And the derivative over here with respect to h will be 0. So this is times lambda. Now this one I could actually simplify because I could divide both sides by r. Now when you divide both sides of an equation by a variable, you have to make sure that that variable is not equal to 0, because otherwise you're dividing by 0. But if this is a soda can, its radius cannot equal 0. Otherwise, it would not exist. So that means I'm safe to go ahead and divide both sides by r. So it says r is equal to 2 pi times lambda. Okay, what about this equation? Well, it's got a 2, a 2, and a 4, so I guess I could simplify it a little bit. I could divide by 2. So it's going to say r times h equals pi times h plus 2 pi times r, and then that's times lambda. And then for this r and this r, I could replace it with this. So right here, separate my work, right here, replace that with 2 pi times lambda times h equals, I guess I could distribute the lambda, no, I'll just wait, pi h, and then 2 pi, and now replace the r with 2 pi times lambda times lambda. And then this side has a lambda, and this side has a lambda. And again, lambda can't equal 0 because otherwise this whole thing would shrink down to nothing. So I could go ahead and divide by lambda. So I can cancel this lambda and cancel this lambda. So this side has 2 pi h equals, now there's no more lambda, so now I don't need parentheses. So it's got pi h plus 2 pi times another 2 pi is 4 pi squared lambda. And next I could divide out all the pi's. So I could get rid of that one, get rid of that one, get rid of one of these. So it would leave 2h equals h plus 4 pi lambda. Oh, good. Now just subtract h. So 2h minus h is h, so h equals 4 pi lambda. All right. Now I have what h equals, and I have what r equals. And I have an equation that's equal to 16, so I should be able to plug those numbers in. So I've got r, so I'm using this equation, substitute this for r. So it's going to say 2 pi lambda gets squared times h, which is this one, 4 pi lambda, and that has to equal 16. We're almost done. So this is going to be squared, so that's going to be 4 pi squared lambda squared times another 4 pi lambda equals 16. And then I could divide both sides by 16 because this is going to be 16, and divide by 16 is going to get rid of the 4's, and then it's going to make this side a 1. And what else have we got? Pi squared and pi, so that's pi cubed. Lambda squared and lambda, so that's lambda cubed. And then you could take the cube root of both sides. And so lambda equals 1 over pi. So go back to here, r equals 2 pi times lambda, which equals 1 over pi. Oh, that worked out nice. And then these cancel, so r is equal to 2. And then substitute the lambda right here. H is equal to 4 pi times what we got for lambda, which is 1 over pi. And so h is equal to 4. So the answers are 2 and 4. And what did their computer say? 2 and 4. I love when that happens. And yes, there is one more. Find the point on the plane that's closest to this. So closest means the shortest distance. So what I could do is, I could do the distance formula. The distance formula from a point to this, first of all, you need to have it set equal to 0. So x plus 2y plus 4z minus 15 equals 0. Now all you do is plug in the numbers. So 1 plus 2 plus 4 minus 15. Because we're talking about distance, we don't want any negatives, so take the absolute value. And for this one, its vector is 1, 2, 4. So the other part of the formula is you divide by the length of the vector, 1 squared plus 2 squared plus 4 squared. So let's see, this would be 6, 7. 7 minus 15 would be negative 8, but absolute value means it's 8. And then this would be 16 plus 4 is 20. This is going to be the square root of 21. But now what do I do with that? That tells me this is the shortest distance, but they didn't say find the shortest distance. They said find the point. Okay. So then I try something else. What I'm thinking is there's a plane. Okay, there's the plane. And then there's a point which is 1, 1, 1. And the shortest distance from here to the plane is going to be when you go along the perpendicular. Well, what else is perpendicular to a plane? That vector right there. So this part right here was fun, but it did not give me what was asked for. But the good thing is it led me to look at this vector, and that vector is perpendicular to the plane. So what I could then do is use that vector. The vector is 1, 2, 4. And if you have a vector and you need to be going in that direction, and you know a point that it has to go through, then you can create the line that contains that point and goes through that vector. And it's very easy to do. It's just x equals, y equals, z equals. Put these numbers in front of t, so 1 times t, 2 times t, 4 times t, and then put the point 1, 1, 1. And the graph of that is this red line. Now what I need to know is when this red line intersects the plane. Well, the plane itself was x plus 2y plus 4z equals 15. And I know what x equals, I know what y equals, I know what z equals, so I could plug those in. So this one would become t plus 1, and then 2 times 2t plus 1, and then 4 times 4t plus 1, and that has to equal 15. So this is t plus 1 plus distribute, so that's 4t plus 2, 16t plus 4 equals 15, And now I know that I'm very close to being done. So how many t's is this? This is 16, that would make 20, that would make 21. The numbers would be 4, 6, 7, so subtract 7 from both sides. So subtract 7, 15 minus 7 is 8. Deja vu, didn't we just do something like that? And then divide, t equals 8 over 21. Now, even though I didn't use it, isn't this a strange coincidence? That's strange. Okay. So now all we need to do is plug in the t equals 8 over 21, and then we could find out what x equals, y equals, and z equals. So this would be 8 over 21 plus 1. So that would be 21 over 21 plus 8 is 29 over 21. This one would be 2 times the 8 over 21 plus 1. So that would be 16 over 21 plus 21. That's going to be 37 over 21. And last, 4 times it plus 21. So this would be 32. And then this would be 21 over 21. So 32 plus 21, that's 53 over 21. So those, or that would be the point that's closest, the point on the plane that's closest to the point 1, 1, 1.